Oh, we're here. All right, let's go ahead and look at this problem real quick. Probably shouldn't be too bad. Remember, what we're doing here is capacitors in series is equal to 1 over C1 plus 1 over C2 plus 1 over C to the n to the minus 1. Okay? Capacitors in parallel, you just add them up. Okay, is equal to CP. All right, so that's equal to capacitors in parallel. All right, that's all we're talking about. That's all we're doing. Okay, so let's take a look at this problem. It says two capacitors are connected to a battery. The battery's voltage is 90 volts, and the capacitances are C1 is equal to 2 microfarads, and C2 is equal to 4 microfarads. Determine the total energy stored by the two capacitors when they are wired in parallel and when they are wired in series. What is the total energy stored when they're wired in parallel and when they're wired in series? So how would we set that up? Well, let's wire them in parallel first. And when you're working with capacitors problems, don't do the 10 to the minus 6 or whatever until you're done. Okay? So we've got a 4, we've got a 2, and we've got this 90 volt battery. Is it 90 or 9? That seems pretty intense. All right, so what's the total capacitance? We're just going to add those guys up. All right, so you get C1 plus C2 equals CP. But then, remember, we had to do the energy. And what did we say energy in the capacitor was? U in a capacitor was 1/2, because it's taken from 1/2 Q times V, but also remember your Q is equal to C times V. And since we're dealing with capacitors, you can just take that, stick it in there. And then you'll do the same thing for them in series. But in series, you're going to use this one. All right. This is a nice little test problem because it kind of tests some things. We can actually figure out the charge on these things too, because look, this is 90 volts right here. So if we knew that that was 90 volts, then we know how much charge is on each one of those. Right? Because of this. This is 90 volts. I know the capacitance, I know the charge. So the charge is going to be more here than here, but the voltage is going to be the same. All right? And then when they're in series, you just use that equation. Piece of cake.